Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guest is John McBride, a senior engineer at OpenSauce. In our discussion today, we talk about how John was able to add AI inference and Gen AI applications to OpenSauce on their own infrastructure. So if you've ever wondered what it takes to effectively run successful ML ops, that's deploying and running inference from a large language model on your own infrastructure in Kubernetes, this episode is for you. That's literally what we talk about. We talk about constraints around OpenAI's APIs being maybe too expensive for scale, and how you could replicate its behavior on your own infrastructure using Kubernetes at your own cost, right? So we talk about taking a large language model, how do you host it, where do you host it, and then how do you run inference against it, and how do you do so in the cloud in a reliable and scalable way. This episode is a really great discussion that is quite technical and goes into a lot of depth around DevOps and ML ops and Kubernetes and Docker, and even some machine learning theory around what makes up a model and how does inference work and so on. So we also outline a number of tools such as Olama that you can use in your workflows if you want to replicate this. So this is a great episode, a treasure trove of information, and I can't wait to hear how you put it into practice if and when you do. Now, I'd like to offer this to all of you at zero cost, and a great way to do this is through the support of sponsors and partners. So let's take a moment to thank and acknowledge them, and then we'll continue with the discussion. The Contagious Code Podcast is partnered with Code Crafters. Code Crafters is a great way to learn how to code and learn the underlying mechanism of tools we use every day as engineers by re-implementing them from scratch in a language that we prefer. So things like Git, Docker, and Redis, you would build your own with Code Crafters in a language that you choose, JavaScript, Python, whatever. And by doing this, you get better at JavaScript or Python or whatever, and you also get better at the tool by understanding like exactly how it works. They have a generous free tier, but if you'd like to pay and get 40% off, you can use the link in the show notes. That's tej.as/codecrafters. The Contagious Code Podcast is also partnered with Stately. Stately is a great way to visualize the flow of state through your application using state machines and state charts, and also model it in such a way that it's robust and predictable. Once your machine is visualized, you can export it to JSON and just fill in the business logic that triggers transitions between states, making your application testable and observable. They also have an AI framework called Stately Agent that helps you create agentic workflows with guardrails that behave in a deterministic way. If you'd like to give that a try, go to stately.ai. Finally, the Contagious Code Podcast is partnered with That Conference, a multidisciplinary, family-first summer camp for geeks. It happens twice a year in Wisconsin and in Texas. If you'd like to attend any That Conference for free, share this episode on social media, say you'd like to do so, and you'll enter a raffle to go to the next one for free. Hey, thanks for sticking around. Now for my discussion with John McBride. John McBride, thank you so much for taking the time to come chat with us today about all the things open source, AI, and more.
Yeah, absolutely. Glad to be here.
I reached out because I read your really awesome blog post about how you saved tens of thousands of dollars deploying low-cost open source AI technologies at scale with Kubernetes. Oh my gosh! Like the keywords in that. Yeah, really. I said keywords because I didn't want to be offensive, but yes, the buzzwords. So cool. And it's an engineering podcast. We like going deep into the details of these things, and so gosh, this blog post was begging for a nice in-depth discussion. So thank you again for joining us.
Yeah, absolutely. Yeah, it's honestly some of the best work I've done in a long time. So I'm really excited to be able to talk about it. Honestly, the accumulation of years and years of building Kubernetes platforms, doing big data app stuff at VMware and Amazon, and now being at a small startup building AI-enabled applications. So very, very excited to be here to chat with you.
Awesome. I can't wait, honestly, to sink my teeth into this, but before we do, could we do a little bit of an intro to yourself for the listeners? Maybe they haven't heard of you, maybe they haven't heard of VMware and things like that. Maybe your background, your interests, and then we can dive into the technical side.
Yeah, absolutely. So my name is John McBride. I'm a senior software engineer currently at OpenSauce, where I'm heading up all of our backend and infrastructure stuff, as well as heading up our AI efforts. Before that, I was at Amazon, I guess AWS specifically, where I worked within the Amazon Linux org building BottleRocket, which is a Linux-based operating system, mostly targeting security and being a container runtime for Kubernetes or these other container orchestration platforms. Before that, I was at VMware building Kubernetes platforms. I was within the Tanzu org building Tanzu Community Edition, so was really deep within the Kubernetes ecosystem of I guess community platforms, enabling people to build on top of open source Kubernetes. Before that, I was at Cloud Foundry at Pivotal, which is no more. It was acquired by VMware way back in the day. But yeah, Cloud Foundry was kind of a precursor to a lot of the big Kubernetes stuff that people are doing today. Yeah, I don't think anybody runs Cloud Foundry like platforms anymore. But yeah, it's all containers all the time now. So that's a bit of my background. You might have seen me online as John Codes. Have some YouTube videos. Was at one time doing TikToks, talking about tech, past life. But yeah, mostly doing some pretty in depth backend Kubernetes stuff now.
Awesome. I used to be a YouTuber. I mean, the podcast is on YouTube, but yeah. I tried to be the kind of YouTuber once that just creates a lot of I reviewed Next.js 13. Here's what you should think, and it never resonated with me for whatever reason. When you say past life, I sort of feel that. Awesome.
Yeah.
Thank you for that intro. There's so much I want to dive into. You seem to have the most experience as it seems with Kubernetes and cloud native stuff. The listenership of this podcast is mostly web engineers that lean towards UI, UX, front end,
Sure.
and now AI as well, because there's a strong intersection between AI and UI, meaning GPT-3 was released and no one cared, and then they put a chat interface on it, UI, and then ChatGPT became this revolution, right? So it's very close.
Right.
Anyway, all that to ask, I'd love to maybe we could start the discussion with a high-level summary of the key points from your blog post, and then dive into each individual component. I think the AI piece is extremely interesting, specifically low cost AI, but perhaps we deal with that later because I think there's a lot of interest just in the Kubernetes piece in the beginning. So
Sure.
Let's start maybe with the summary of the key points and then go from there.
Yeah, absolutely. So in short, the post is really kind of chronicling a journey that we went through at OpenSauce, building this AI piece of the platform called Star Search. And, kind of to tee this up for what Star Search is it's basically a chat-enabled part of the application where you can ask about things going on in the open source. You can ask about experts in the open source. And what we've really fed this thing is just a bunch of stuff off of GitHub to really inform who are the experts and who are the who's who of what's happening in open source. So you can ask it questions like, who are experts in Tailwind and Rust? Maybe I'm hiring for somebody who needs to know both those technologies, which are honestly not very closely related. But you can actually tease out some of those people using Star Search. Or maybe you're working on a feature in a massive community. Maybe you want to add a feature to something like VS Code, Microsoft / VS Code and GitHub. It's a pretty heavy lift just because there's so much happening in that community all the time. So many different people, obviously at Microsoft, but also within sort of the open community. And so you can use that to then figure out who maybe you need to reach out to get some sponsorship for some of your changes, all that stuff. So obviously, anybody who's built AI-enabled applications or specifically retrieval augmented generation, oftentimes called RAG, you'll know that you just need to have just a mass amount of data embedded into a vector store to be able to do that. And really, I've realized that there's just so many things in the AI space that are just weird nomenclature that oftentimes doesn't make sense. Really, embeddings in vector stores is just we have the data, we sent it through a machine learning model, and now we can go and query it using a vector search or some really fancy search algorithms and just get it. So then we can feed that to an AI model, and then it just has context on top of that stuff. So it's easy to say that and break that down, but really in the end, what we ended up doing was consuming a lot of this data, which powers the open source platform today. It's a lot of this time series data to be able to see contributions over time, to be able to see pull requests over time and all that. We took all that, we sort of broke it down, and initially our approach, and this is kind of, what we we're spending a lot of money on initially, which we'll get into the cost stuff as you said later. We were just sending all that to OpenAI, and it was just doing OpenAI's text embedding, models to actually embed it into vector space. We were using the chat capabilities with like GPT-4 and all that to actually just power the back and forth. And we found that it was pretty quickly at the kind of scale we were targeting. It was astronomically expensive. Excuse me. It was astronomically expensive. It was like going to be in the magnitude of like hundreds and hundreds of thousands of dollars a year just to do kind of the back and forth within the pipeline that we had. And we can get into depth and like what that actual pipeline was. So that was where we started, was like, wow, this is going to be really expensive to target the kind of scale we wanted to target right away, right? What are the alternatives? Well, we're going to need a platform to run some compute on, specifically GPU type compute, because we knew that it was going to be, something that was going to be running a model to do the back and forth we needed to actually power this application. Okay, I know Kubernetes. Kubernetes actually is very, very good for running different types of compute within the same cluster. So you could have a bunch of GPUs. You could have a bunch of different types of GPUs, all labeled different ways. You could have powerful high memory nodes in your cluster. You could have, just simple little, fast spin up, spin down type nodes doing all different kinds of things. So I felt that was a good solution if we were going to take on kind of the heavy burden of doing compute on a platform that then we were going to manage. So that's maybe another important piece of this, is it was really kind of lifting and shifting off of a third-party service onto one that we're going to manage, a compute platform that we're going to manage off of the public cloud, and then be able to power that entire pipeline. So really, I think at a very high level, that's kind of the antithesis of this post, was like using a third-party service, primarily OpenAI, was very expensive, very, very expensive. Yeah. I think obviously to anybody who's built this stuff before at any kind of scale. Then lifting and shifting onto our own platform powered through the through the public cloud on top of Kubernetes with a bunch of GPUs. So that's really kind of at a high level, like what we did there. And I think this post was important to me, especially because I could not find really any prior art on this. You Google online, like how to build a RAG pipeline or like how to like build AI enabled applications. And it's all just like, well, you want Llama Index, or you want, what's the other one? One of these Python Uber libraries.
LangChain or something.
LangChain, yeah. You're going to use LangChain. You're going to give LangChain your OpenAI token, and boom, it's done. That just doesn't scale, unfortunately. I guess it scales with how much money is in your bank, but we as like a tiny, small startup who wants to, provide this value to the open source, found that would be immediately unsustainable. So, that's really kind of the antithesis at a very high level.
Awesome, thank you for that. I think I think this is so cool because scale is indeed the determining factor for how much you pay with these AI applications. So I'd love to actually compare notes with you because my website also sees a significant amount of scale, I would say, and a lot of it is using the podcast search. So we've got if you go on tage.as, we've got this podcast search.
Yeah,
obviously these episodes are super long, and not everybody has time to listen to this one shot. So what they'll do is listen incrementally, but sometimes you just kind of want the answer. And so we have this search where you just type in like resource hints, and you'll get the exact moment in time where Dan Shapir mentions the word resource hint, and then you'll capture that whole conversation. So that's a pretty heavily used feature. I also learned the hard way that this is way too expensive for me to sustain. And so what I've opted to do is something entirely different than what you've done here, mainly because I don't know Kubernetes. And this is why I'm super interested in the Kubernetes portion of our discussion later on. And maybe we should even front load that, because what I did was maybe something super naive, right? Like it was, I first started with semantic caching. So each prompt with its response that is later generated is stored in a vector store. And then we just do RAG, meaning if a question is similar enough in spirit to a cached question, then we serve the cached answer. So that already saved a good amount of money because people were just asking the same questions over and over again, or some permutation of them. And then the other cost saving strategy was to create a fine-tuned model based on, we were using GPT-4 Turbo at the time. And so we then we took Mistral 7B, which is an open source model, and we fine-tuned it on a huge amount of responses that were automatically generated by GPT-4 to prompts. And so Mistral 7B would respond in exactly the same style as GPT-4, but at a fraction of the cost. A fraction of the cost meaning because it's a significantly cheaper model to run in terms of API costs. And so that, for me, is what makes the website sustainable. And the fine tune is only serving a response if it's confident enough in the response, and if not, then we still proxy the request to OpenAI in the end. So it's not that we don't use OpenAI at all, but we use OpenAI less, and that has worked really well. So I'm with all of that, I'm really, really interested in the use of Kubernetes here, because I'm like, what am I missing? What has worked exceedingly well at open source in light of this article and your research that maybe others can glean who have already maybe gone down my more naive path?
Yeah, that's a good question. I mean, this. I want to preface this also with saying that this isn't a knock on OpenAI. I mean, we still in the end use OpenAI to sort of formalize the final response, which is much more sustainable than having to do vectorization, summarization, et cetera, all in one big bundle that ends up being very expensive. But I think some of what I took away at a high level, to answer your question, is that really good AI features, applications, and things is really just good mass at scale data engineering, which is honestly a relatively not solved for problem, but there's a lot of good prior art in that regard. So take whatever we've done and just forget AI. It could be image storage. It could be blob storage. It could be caching. It could be some piece of data, whatever that we're trying to do at scale, and just, drop in and replace that. And it still actually works pretty well, where we have a Kubernetes compute platform doing some stuff. It has some small microservices doing some processing. It has some, a database that it sends some stuff to, et cetera, et cetera. So when people ask me hey, John, what should I what material should I read and learn about to do any kind of AI at scale? Because anything much past the kind of simple LangChain script thing is going to be requiring a bit more, I think. I usually actually recommend the Building Data Intensive Applications book, which I forget who it's by, but it's a masterwork. It's an absolute masterwork in building these kind of huge scale data pipelines and applications that you can serve that data out of, and configuring and moving around databases to be scalable and getting all that configured. So that's kind of my hot take, is that at this level, at this high scale, sure, you have your RAG, you have your caching stuff, you have vectorization, all that. But beyond that, it really just becomes an exercise in data intensive applications. So really, to answer your question now, in my opinion, Kubernetes is an excellent, absolutely excellent platform for servicing those types of huge scale applications. So to put this in context, what we targeted initially for Star Search is to be able to look at and inspect and vectorize the top 40,000 plus GitHub repos on the platform, which ends up being about anything over 1,000 stars, which is honestly a small subset of GitHub. GitHub has...
But by repo, what do you mean? Do you mean the contents of the repo as well, or just the metadata of the repo? The name, the language?
Good question. So when I say repo, I'm probably too close to the problem, so I just imagine everybody knows what I'm talking about. When I say repo, I do not mean the code.
Okay.
That would be a bit of an anti-pattern at this stage for us to basically rebuild GitHub Copilot or Source Graph Cody. Everybody's looking at the code. The code is not that interesting, honestly. What we look at is, yes, all the metadata, but then also what people are saying in the issues, in the issue comments, in the pull requests, in the pull request reviews, because you can't really, well, you kind of can, but it'd be very hard to figure out who are the experts in certain domains within given projects or even like ecosystem of projects. It'd be very difficult to figure out who are the domain name experts, the domain experts, or the like who's who of doing some things. So being able to ask a question like hey, does John what has John been working on? Sure, you can get to that, but being able to ask a question like, I need help in Kubernetes or Microsoft VS Code or Facebook React or any GitHub repository. I need help implementing blah 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 this thing. Who are the domain name experts that I could maybe like reach out to and get some help, or maybe get some sponsorship to bring those things upstream. That was a huge focus of this initially, was being able to kind of zero in on not really the code, but like all of the things people are saying ancillary around the code. So I will say, I mean, it does give some kind of bizarre opportunities for the models to, I guess, hallucinate. We've been saying ungrounded responses, just because sometimes people give like total garbage like responses inside of GitHub pull requests or issues. A good example is when Facebook React open sourced the React compiler. All they said in that pull request was, "It's open," which doesn't tell you anything about what Facebook React compiler actually is or actually does. So then, that's ample room for the model to be like, well, I see the name of this pull request. I can imagine maybe what the Facebook React compiler is. But anyways, that's a moot point. So all problems that any, large language model enabled thing has to deal with is you're gonna face hallucinations and ungrounded responses. Anyways, yeah. So it's looking at all that ancillary stuff. It's all the stuff that people are saying in comments and issues and pull requests. That kind of then informs a lot of the responses that get sent through those data pipelines. There's a lot of like summarization that happens kind of under the hood, where we do try to strip off a lot of metadata, because oftentimes pull requests have just a bunch of metadata cruft. That's really where the giant cost to OpenAI was going, was like, we need to summarize these 50 pull requests. Okay, that's like 50 back and forths with OpenAI just to like generate one kind of summary, right? Yeah, does that kind of answer your question? Give you a better picture of like where we were targeting with that kind of scale?
Yeah,
it's also in real time. I'll say that as well. Is we have those 40,000 plus repos, and we consume this fire hose off of GitHub, and we're just constantly getting stuff. So some very, very rough back of the napkin math. Let's say that there's five. There's 5 of these events, these comments, pull requests, issues, or whatever. 5 of these events that happen in each of those GitHub repositories every day. That's 5 times 40,000 is, oh gosh, what is that? 200,000. Yeah, so 200,000 events that we need to consume. 200,000 events a day is well over like, I don't know, 50 million something a month.
Yeah.
You keep going at that, and it just becomes honestly ridiculous. And 5 events in each of those repos a day is very conservative, because oftentimes in really big projects like Kubernetes, React, VS Code, whatever, there's many tens of those events happening every day: pull requests, issues, comments, etc. So that was the kind of scale that we immediately needed to build up to. Honestly, because we had the benefit of the doubt of having the data and having that fire hose pipeline. So it's not like we had to build up like slowly, right? That's maybe an important preface too, is that, maybe some builders or startups, or even in your case with the podcast, like if you had 1-2 podcast episodes, I'm sure that's just like, there's not that much data to actually parse through. It's fine. We'll just build this thing with, a one shot to OpenAI, and it's fine. But then as soon as you get, a couple hundred podcast episodes or something, or like many thousands and thousands of vectors that you need to actually store and go through, a one shot starts to make no sense at all and gets very expensive.
Yeah, definitely. Yeah, thank you for answering that question. It does indeed help to understand the model.
Yeah.
And exactly, I think the scale is enormous. So it's this live stream of events in these repos that you'll, if I understand correctly, you receive the events, you immediately then vectorize them, store them in your vector store. Your article, by the way, said vector store. I'm curious which one. And then when a user submits a query, you do a quick lookup and then generate text with an LLM. I think this was the initial approach, as I see in the blog post. Right, this was
Yeah.
the first wave was this. You pull a bunch of stuff from GitHub, vectorize it, store it, do a similarity search when a user submits a query, and then serve the response.
Yes.
I think there's, as you mentioned in the blog post, even there, this is not bad, right? Like there's a great structured API, there's good libraries, OpenAI really helps you. I guess when did this start to become painful is my question. And maybe
Yeah.
a pre-question is what vector database are you using?
Yeah. Yeah, that's a good question. We're using TimeScale actually, which is built
Okay.
on top of Postgres. So we use PG Vector under the hood, and that's a very odd choice, actually. I would say the reason that we picked or are using TimeScale and by extension PG Vector on top of that is because the events fire hose that we're consuming is primarily it's an events-based fire hose. So everything has a timestamp. Everything is kind of the full picture of what's happening on GitHub over a course of time, almost like a conversation where it's like you'll see a pull request event come in, and that signifies a pull request was created. You might then a couple hours later or whatever see a review event for that pull request, and then a couple hours later see that one closed and merged. And then because of that, you'll see a push event when it was merged onto that repository. So you get this whole like picture of stuff happening because all these events are just flowing through. So in order to enable, the histograms and charts and time series that exist on OpenSauce, we needed a very big performant the time series database to be able to store those time series events in and then be able to query those out of for all the histograms and charting and all that stuff. So that's really like where we started from. That's what we had built first, was like consuming everything off of the GitHub events firehose, throwing that into a time series database, which we had chose Timescale, and then being able to like propagate charts and whatever. So like if you go to app.opensauce.pizza/org/name, whatever repository, whatever you want. So like s/Kubernetes, you'll see all those charts and all those things that are powered by that time series database. We knew very early on, probably around this time, maybe like 8 or 9 months ago when I was building this thing, we knew that we were going to want to build in AI capabilities eventually. And we looked at a bunch of these different vector stores. I mean, we looked at Pinecone and Quadrant. We built some stuff on top of Quadrant. I really liked it. It's very, very fast and very, very good. But it sort of befuddled us to like have to replicate a bunch of this data across what was in our time series database and then what was going to be inside of a vector store. And then at one point we were considering this like crazy architecture of like, there could be, the time series database that has all the metadata and all the stuff on the actual events happening on GitHub. So replace event with pull request, issue, comment, anything, all of it. We have all that metadata, all the text, all the stuff. That's in the time series database. What if we like replicate it across to like Quadrant and then have these foreign key references that would then be able to like link back to the time series database, but across databases? At that point, we're basically reinventing Raft or some like distributed database technology.
Exactly.
Disgusting. No. Immediately.
The amount of problems you'd create for future you with decisions like that, I think outweigh any benefits you could have in the short term, right?
Exactly. I mean, I think once we started going down that path, it immediately became clear to us, and honestly, just as like thought experiments, we're like, yeah, this is probably a bad idea. Let's pick a time series database that has vector capabilities already built in. Oh, Timescale is built on top of Postgres. Oh, Postgres has PG Vector, which is getting very good and only getting better, and seems to somehow be outperforming some of the best vector stores these days. So I mean, in my opinion, we knocked it out of the park with that decision where we're not replicating data. We're not like having to do some weird, crazy distributed database thing where we invent a bunch of problems for ourselves, like you said. We now just have the time series data. It sits in rows in the database, and then additional rows for vectorization of those, and then a simple timestamp for when it was vectorized. So if we ever
Interesting.
need, so if we ever
So
needed to go back and like say like anything older than this, just clear or whatever in the Postgres, and it's actually worked. It's worked phenomenally well. I think last time we checked in with Timescale, and this was maybe like 3 or 4 weeks ago or so. They said that we're the biggest user of vectors on their platform, and I think it was something like 40 million some vectors or something stupid like that. Like, it's grown quite significantly, and we've had zero problems with being able to query stuff out of there. It's quite. I think at some point we'll reach an additional scale problem where it's like, oh, we have all these vectors. Do we start dropping vectors? Do we like do something fancier where we have like, I don't know, maybe we like cold storage some vectors that we don't need because it's all time based, right? Like people probably
yeah,
aren't going to be asking questions about stuff happening like 2, 3 years ago. Can we just drop
yeah,
those? Can we just like move those into cold storage? Those are problems for future me. So
yeah.
we'll figure that out when time comes. But yeah, that's the answer on why we chose timescale. I think it's kind of a bonkers solution, honestly, mostly because I don't imagine a lot of people need a time series database that also has AI vector capabilities,
Yeah.
right?
Yeah, but I appreciate the thought that went into it, and it does sound like based on your unique needs to show these graphs and use and build AI enabled features.
Yeah,
You did not. It's like I would also probably make that decision given enough time and context.
yeah,
I have a follow up question. You mentioned you store your events as rows, and then you have vector rows as well.
yeah.
If I guess your schema correctly, would that mean you have like a foreign key between two tables, one for the events and one for the events as vectors, and you like have a linking column between them? Or
No,
is because the other way I think of it is the vector of the event could just be a column in the event table. And if any
exactly.
of this is proprietary, don't feel free to like tell me to stop asking. But like,
Ah,
is that how it is? Is there just a vector column with the vector for a given event?
yeah, I think
Okay.
I wrote a guest post for Timescale that goes into
Nice.
depth on this. So it's somewhere in Timescale's blog, basically going from like nothing to how we built like the tables and stuff for the histograms and time series, all the way into how we built the AI capabilities, and it's exactly that. So vector is just an additional column inside
Awesome.
of our main events table or tables. So
Yeah.
each table is its own event. So there's the like GitHub pull request events. That's its own table. There's the issue pull request events. And that sort of made sense from the very beginning to be able to sort of segment those by like event type or flavor, I guess. Just so we didn't have one like stupid Uber table that needed, event. Because we do all kinds of filtering where it's like, well, we really only care about pull requests in this context, or maybe for this chart or something. So let's only query the pull request events table, right? Again, I go back to this. It really just becomes a significant exercise in data intensive applications. This is all stuff that you would like have a pretty good understanding of if you had been at Amazon building these kind of giant scale things across many different data centers, or doing anything with a lot of data that had to be stored and retrievable efficiently, right? The AI part of this really is not that interesting. Just becomes kind of an exercise in doing vector search and then sending it to a model. And then maybe some of the interesting stuff is actually the like prompt engineering and a lot of that we've done, which we've actually poured significant work into, and we can talk about that as well.
Yeah. Yeah, exactly. It's because the rest is calling APIs as far as I can hear, right? The data modeling piece is so intense, which is why we should put a link in the show notes to both the blog post you mentioned for Timescale and the book for people to buy, Designing Data Intensive Applications. I have seen this
Yeah.
cover. I haven't yet read it, but I've heard nothing but praise from literally everybody about this. So I think it's definitely worth a read
Yeah.
and a share.
Yeah.
Okay, so that second question: at what point did y'all you build Star Search with this initial approach where you get a bunch of stuff from GitHub, turn it into vector embeddings stored in the database, and then just do rag, the naive way. At what point did that start to become painful? Because I have to assume there was some type of like celebratory period, like, oh yeah, it's working, it's great, people are
Yeah.
using it. We did a launch even maybe, and then you're like, oh, whoa, what's happening to our runway? Are we gonna have to like lay off a bunch of people?
Yeah.
When did that moment come, and what did it feel like?
So that's a great question. There's a fun story here. So when I initially built all this, the precursor work was all of that, like GitHub Firehose into Timescale. We have all these charts and all these things on top of it. Now we're going to build AI-enabled capabilities with a vector column, and then some microservices that are going to do like calling APIs, yes, but also doing some summarization of all that stuff to kind of enable some of the use cases we had defined. So I think at first, excuse me, I think at first I had maybe turned it on for like 50 repos, and it was like, this is great, it's working, like, oh my gosh. And at that time we were all going to go do an offsite in Miami, and it coincided with React Miami, so we all went to React Miami, and tons of fun connecting with all those people, that community. Brian B. Dougie on the internet, our CEO, he gave a talk there and kind of talking about like how we built some of the charts and capabilities using some of the React components and stuff we built. So it was a great time. In that whole offsite, it was kind of like, okay, guys, we're going to do this. We're going to turn it all the way on to the 40,000 plus whatever repos that we've just targeted and have defined as like, this is a success at scale. We turned it on. It worked. It was, just chugging through all of those. And then we started to see this like, like hockey stick curve on the OpenAI bill. And we all were getting like the OpenAI emails that were like, hey, your account has been billed an extra like $200, like every few hours. And we're like, oh, what's going on? Like, oh my gosh. And I had this moment where I was sitting at dinner with everyone, and I literally back of the napkin, like wrote out some of the math, because we're getting all these emails at a pretty consistent rate. And maybe to the benefit of this being kind of a pretty stable subset of repos we were targeting, I could kind of like just write out the little back of the napkin math at dinner. And I was like, and I think I said something to Brian where I was like, Brian, this is how much this is going to be to like do this the way that we're doing it right now, or basically the way that I built it. And he was like, oh, wow. All right. I was like, I'm going to fix this. Like this, I told him, I was like, I'm going to go back. And like, I think we had talked about doing a launch for it at that scale. And I was like, oh, we should really consider like spending time, dedicated to, some cost optimizations here. And, in the back of my mind, I had a pretty good idea how to go about this, having kind of explored a lot of the inference engines, like OLlama, and obviously llama.cpp is a huge one. And I was just like looking at a bunch of this. So I knew it was definitely possible on hardware or on GPUs to do basically what we were getting out of OpenAI, just probably slower, and maybe using not a GPT model. So yeah, it was, to answer your question, it was almost immediately where we turned this on. I'm doing some back of the napkin math, and I'm just like, oh God, like, wow, this is crazy. Holy cow. So that same week at React Miami, I'm just like at a hotel on Miami Beach, like being like, oh, I guess I have nothing else to do besides, like sit in the heat or like work on this thing. So I quick like pounded out a proof of concept and basically had it turned around again within probably another 2 weeks or so. And this is the, maybe even less. This is sort of the benefit of being able to like work at a very small startup with like a very small agile team, is we were basically able to pivot off of what we had done. And then I could go and kind of reinvent some technology, or really just lift and shift, as I had said. And that was all of another, few weeks. And then we had the costs down. So that screenshot of our OpenAI bill, if you actually look at it on that blog post, it's probably like 4 or 5 days where it's just like hockey stick up, and then it's kind of flat. And then we turned it off and then flipped it to the Kubernetes stuff. And it was yeah, okay again. Um, there's a bunch of stuff in there that we could probably get into, but I'll pause there for effect.
Oh yeah, no, that's brilliant. I can only echo that I've had the same experience the moment I shipped my podcast website, the podcast search thing, because it
Yeah,
wasn't just the podcast search. There's a podcast search. I wrote this book on React, and you can learn anything about React from the book by doing drag, and then there's
yeah,
also. I thought just for posterity, I'll just do like a me search. So I downloaded everything I've ever posted to X ever. This like 50K records or something like this, and again,
yeah,
vectorized everything, put it in a database, and that's people can search and literally ask anything. And if I've tweeted about it, then they'll get an answer.
yeah,
And
yeah.
not just an answer, but also an answer like click here for the like original tweet to go read it yourself, just in case
Nice.
you are missing content. Yeah. So that those bills also, I had this moment where I was like, oh my gosh, can we afford this? Is this especially because this isn't like a business thing? It's just my personal website, man. Like
Yeah,
I don't know if I. And so yeah. And then I started looking at serving a fine tune and things like that. Okay, so you brought the cost down. I think this is the ideal segue to
right,
to the cost savings, right? This was
right.
obviously the tipping point to explore. What was the first thing that you all dived into in terms of cost savings? You mentioned Olama and Llama.cpp, etc. But was the first idea, the first direction, let's find an open source LLM, or was it something else?
Yeah, it. We very briefly considered like trying to go find some additional credits somewhere. You know, open like startup life. You know, we could go find some credits and like start using a different third party thing because at one point we had a bunch of OpenAI credits, but I think they had expired or like the usage for that giant chunk of credits expired. You know, and like credits are great until they expire, they're gone, and then you're eating a big cost of that. So in my mind, and kind of aligning with an ethos of open source was pretty clear to me that we were going to rebuild this with some open source or like I guess source open, whatever you want to call them, models out in the wild. And just to be safe, we just picked probably the most permissible ones that had the Apache license, which are the Mixtral models. So Llama 3 and Llama 2 and the Meta ones are great, but like licensing definitely is something to be very mindful of, especially if you're going to start serving this in a platform that has pricing and payments and blah blah blah. So obligatory. I am not a lawyer, but we picked the one that seemed to be the most permissible. And maybe a quick tangent on like how I like to work and how I like to think. And maybe you've heard this from other ex-Amazon people before, but I really actually like the process of writing out like a pretty good proposal, having that reviewed by people, and then kind of going forth and doing the work, which can be a little waterfally at times, but just being able to like from a very high level kind of design and think through what the actual implementation of these features is going to look like can just be a really helpful way to kind of steer you away from obvious pitfalls. Like that whole thing we chatted about before where it's like, oh, we could use Quadrant and then have this like whole like crazy distributed database thing. That was all thought through in a design doc. So we weren't even hands-on code. It was all kind of a proposal I had written, kind of thinking through that. And then at the end being like, this is not recommended because ABCD, whatever. Whereas maybe in a more, naive approach, you would have just started throwing stuff in Quadrant and then, maybe weeks, months later been like, oh, this is a problem that we've created for ourselves. But we're already using, Quadrant or whatever. So I just say that because, and, I think maybe it's obvious to some people that like, oh, of course you'd want to like think through and write through some of the stuff that you're going to like go and implement. But I don't feel like it's always obvious in the most like extreme agile kind of workflows. And I've done both sides. When I was at Pivotal working on Cloud Foundry, we were about the most extreme programming that you could possibly do. I don't know if you've heard about this before, but at Pivotal we did pair programming all the time.
Oh yeah,
100%
I've seen
of the
that.
time. And it doesn't exist anymore. And maybe it was a 0% interest rate phenomenon where you could have two engineers working on the same thing at the same time all the time. But the whole process was a little bizarre because you never really had a clear cut direction. Sometimes you would, and usually that was the tech lead's job. But you never always had a great clear cut direction at a very high level where you were headed. You sort of just had a ticket that had like the user, story in it, and you and your pair were going to work on it. And then that was kind of the end of it. And maybe you wouldn't see that bit of code again for kind of a while. And at its worst, I found that sometimes it would create this like massive disconnect in like what at a very high level the actual platform or product was moving towards. Whereas at a boots on the ground, at the bottom, the engineers were just kind of cutting and finishing tickets and could create a pretty massive like rift in like general high level product direction or platform direction and actually what was getting done. So anyways, I digress. All that to say is I wrote a giant proposal about all this before I even like hands-on coded it. And that kind of became almost a manifesto to like, we're moving a bunch of this off of OpenAI. We're going to adopt an open source model to do some of this. Okay, if we adopt an open source model, we need to adopt an inference engine. Okay, if we adopt some inference engine, we need to have some compute platform doing something. Well, that probably means some GPUs so that it's actually performant. And then, Kubernetes seems like an obvious solution for us to be able to lift and shift rather effectively. I'm sure some people will disagree with me on this. Kubernetes, in my opinion, again, is probably one of the best platforms to do this kind of like batch processing, distributed, compute across many different computers, basically. And maybe for your audience, I'll give a quick kind of my view on Kubernetes. Sure, it's a container orchestration platform. What does that even mean? It just means that you have a bunch of computers all hooked up together. They're all basically on the same network, even though they're all probably distributed across some data center or whatever. You have a bunch of these computers all, managing different containers all at once. And that's really the magic of Kubernetes, is being able to, add and remove computers at any one given time. Maybe those computers have GPUs and such. And then you can actually do some pretty great sort of fancy labeling where you say like you are a container that needs to run on a GPU. These computers over here, these nodes in this cluster, they have a label that enables you to run on their GPUs. Go forth and run on the GPU, right? And that feels easy to say, but in computer speak, that's pretty hard to do actually without a mass mature platform. So yeah, that was kind of the whole thought process around actually adopting Kubernetes.
Thank you for that. That was a really great detailed outline. And I think what we can do from this is actually extract a reusable, reproducible formula for the listeners to go forth and self-host their own AI engines, so to speak, for LLM inference in their applications, right? Because let me just say back to you what I heard as your formula, which was, okay, you recognize you're going to need an open source large language model, so you pick the Mixtral ones for licensing. But then you're going to need some inference engine, something to actually run the model and give you the inference, the output. And you're like, okay, what is that? I guess this is Olama. We'll come to that. And then, okay, this runs on local host, but how do I get in the cloud? I'm going to need a way to run this in the cloud with some type of cloud containerization service, aka Kubernetes. Yeah. And then finally, I'm going to have to expose all this to the internet, and I'm going to need some GPUs. And so Kubernetes is great because, as you mentioned, you can map like container to machine very easily with some labeling. And this is literally you set a label in YAML, right? As far as I know.
Basically, yeah. In Kubernetes, they're called taints or tolerations, but it's the same thing. You're basically taint and toleration. Yeah, you're basically just labeling a container onto a node. Crummy vernacular exists everywhere. Be it in React land. Like, it took me forever to figure out what the heck a server component was, and then I was just like, it just runs on the server. Like, they could have just said that, but it's named a certain way. Kubernetes AI, there's crummy vernacular everywhere.
Yeah, also like use effect, which doesn't actually. It has messed up the definition of the word effect for it's got a capital E for a reason. Yeah, totally. Okay, so let's dive a little bit into this picking the open source LLM thing. You mentioned for licensing, but I'm curious what other key open source projects were considered. I maybe we can also draw a line between a lot of our listeners are confused about the various terms they see. And I'd love,
Yes.
we talk about eliminating imposter syndrome in this podcast and making this stuff more accessible. So, inference engine is Olama because it runs the model,
Yes.
and gives you inference, gives you output. But the model itself is just a big, like a 40 gigabyte file, usually with like the extension .gguf or a bunch of like .safe tensors files, right?
Yeah.
And so you've got like a huge multi-gigabyte file, which is just the model itself, which is, you can liken this to just a huge JSON object with a bunch of different weights. You hear
Yeah.
7B, that's 7 billion parameters, or in a very crude, oversimplified way, I'll probably get in trouble for this, but 7 billion if statements that maybe are not, they're maybe not, so that's maybe too much, but it's just, there's a numeric probability of what path to take, called a weight. And so 7 billion of those, which is why it's so big, but that's just the model, and then you need a file to run them. So as we talked about, Olama is the inference engine. The model is big. I've heard llama.cpp, and a lot of our listeners have also heard llama.cpp just in the wild. Is that an inference engine or a model? What is that? And did you all I think I read a reference to this in your blog post. That's why I'm asking.
Yeah, that's a good question. Llama.cpp is one of probably the biggest, honestly, inference engines. And it's written in, obviously, raw C++. Much like the core tensor engines are. So if you go on GitHub and look at like, Tensor or, a bunch of these Python libraries actually are just C++ libraries that have Python interfaces into them, which you might ask yourself, like, how the heck is Python so fast and the choice for most like machine learning and AI? Well, because it's really just C++ under the hood. That's, very performant and very fast doing, all the neural network stuff. So yes, as you said, these models really in the end are just weights, sort of, sometimes I like to think of them as like definitions for how the underlying neural network should be run by one of these engines. So Llama CPP is one of probably the biggest of these engines. Olama actually uses llama.cpp under the hood. I don't know if a lot of people realize that, but llama.cpp,
I didn't realize that.
Yeah, it's and they've done a ton of work to, make that experience much better, because you can use llama.cpp as basically a command line tool. It's just really gross. It's just really rough. I don't think that's a core tenet for, people working on llama.cpp like that. And maybe that's good because it leaves a lot of room open for people to build on top of llama.cpp and build better user experiences and build better optimizations that then hook into how llama.cpp works. Like, you try to run llama.cpp and there's like a million different little knobs and fine-tuning things that you can do to like change how the engine runs. Where Olama just is kind of like, we have an opinion on how this should run for your hardware. Oh, you're on a MacBook? We're going to tune llama.cpp under the hood to be pretty good for how it runs on a MacBook.
That's cool. I didn't know that.
Working. Yeah. There actually really only exists a few true inference engines, llama.cpp being one of them. You can obviously run the like CUDA, the CUDA libraries yourself, which is also kind of gross. VLLM, which is actually the one that we ended up choosing, is another one of these that uses, I think it uses the CUDA stuff under the hood. It's kind of wild how, it's like kind of the layers you end up getting, where it's like, sure, there's like all the crazy tensor stuff under the hood maybe, or people like building on top of like proprietary CUDA libraries or whatever. But then another layer up of like, the sort of llama.cpps and the like core inference engines. I think another one, I might be misremembering this, but Hugging Face Transformers also has a bunch of like C++ that just, runs an inference basically on a model. You could choose to use that at that level. But then another level up might be Olama, where it's like using one of those under the hood, right? And then probably another level up from that is like some of the like Mac OS applications that use maybe one of those kind of lower level inference engines to give you some of that. So it's a lot of abstracting away this stuff. In the end, we looked at a bunch of these. There's another one I'll mention that I think is really interesting from the people at Mozilla actually, who obviously bring us Firefox and Thunderbird and a bunch of that. And it's called Llama File. And I think it also uses llama.cpp under the hood, but Llama File actually bundles up a bunch of this stuff almost like a Docker file in kind of a single composable model plus engine plus, and it's just one single binary, and you just run it, and it just works. And
Wow.
you can sort of define how that should work and how that should run. I'm very excited about that project because obviously I love containers. I love how you can define like a Docker file to just like work across many different types of architectures or in a certain way. So yeah, go check out Llama File. It's also very cool. I think the ones that I'm most bullish on. Well, honestly, I think Ollama sort of has won at that level, partly just because of their community engagement, but also just the really excellent user experience. Ollama is, I think a bunch of those people were at Docker at one point, and kind of left to go, and it's very clear to me that like, oh, they just know how to build a great command line experience, and like Ollama pull whatever is just awesome. Like that, that's exactly the experience I want trying out a new model. It's just like, I don't want to have to go look at the Guff files or try to like figure out the quantization I'm going to use on, which is just like, I don't know. At that point, you've like gone too deep. In my opinion. And it's just like, man, I'm not a data scientist. I'm not an ML researcher. Like I sort of don't care. I just want to run the thing and build applications on top of it. So I'll wrap up this rant by saying, you got to ask yourself a little bit like, at what level do I really care? Who am I? Am I an AI ML researcher? Then you do care about the like point precision of numbers inside of your model. Are you building applications or trying to like ship some stuff? Use Ollama. Use something that like just abstracts a bunch of that crud away. At some point when you've unicorned, sure, you can. At that point, you can decide to like use something or fine tune things with all those little knobs and those little things within the libraries. But that's just a sunk cost fallacy in my opinion. So what we ended up deciding to do to wrap all that up is we picked VLLM for a few different reasons. At the time, and this has changed, at the time, VLLM was the only inference engine that could serve an OpenAI compatible API to multiple clients at once. So there's a bunch of stuff that I just said. We knew that we didn't want to have to change a bunch of the client code in this whole like pipeline gargantuan thing that I had built. Or we could have. It just would have been more work to like lift and shift the client code to something else. But it seems that so many of these libraries and really the industry, they have sort of just kind of thumbs up and decided that the OpenAI API is like, that's what we want, is we're going to be using OpenAI's API. And that seems to be a well-structured API. And we'll just use that in our thing. And you want to like use our silly little library? Okay, it's got OpenAI's API in it, or like we're going to instruct you how to use OpenAI's API as part of it. So at the time, VLLM was one of the only ones that would serve that API to then do inference, but critically to multiple clients. So we knew that if we were going to be doing this in a Kubernetes cluster, we wanted to like basically parallelize it and have it be able to service many clients accessing that endpoint as if it was OpenAI, and just kind of be like, this is OpenAI's API endpoint, but wink, wink, it's actually VLLM, and do that across many different pods within the cluster. Maybe another little side tangent about Kubernetes is you can basically infinitely scale whatever you want on top of it with your deployments, with the number of containers you're running on the cluster. The possibilities are basically endless. So that gave us that capability to scale up some of those operations within the cluster behind an OpenAI compatible API with VLLM. And I said that things have changed recently because at the time, Ollama was offering an OpenAI compatible API, but it was not serviceable by multiple clients at once. It basically, you could have one client connect to it, and if another one tried, it would just basically just hang and fail eventually. And that's partly just some of the things that they're kind of still ironing out as far as like how they interface with llama.cpp, because I think that was something that llama.cpp couldn't do for a little while. But even llama.cpp offers an OpenAI compatible API under the hood, so it's sort of pass throughing a bunch of that stuff. But long story short is we picked VLLM for that reason, and it's also extremely performant. It's another probably top tier inference engine. I would consider right next to llama.cpp, but these things change so fast, like ridiculously fast. Like I wouldn't recommend anybody try to like keep up with the AI Joneses because you're just going to go crazy trying to stay on top of the like latest and greatest and hottest little thing. If it works for you and if it's like, performant enough and giving you the inference that you need, then you could probably stick on it for, as long as you need until maybe a new standard comes around. Because in my opinion, today, there's no standard. Maybe besides OpenAI is kind of the standard, but even that is like changing quite frequently, pretty drastically, right?
Yeah, no, I have to say, John, this is one of my favorite discussions I've ever had on the podcast because what I'm hearing from you is like extremely thoughtful decision making based on constraints that are somewhat unique to your problem set, to open source problem set. Because like the requirement to serve obviously multiple concurrent clients, and to do that in a performant way because you've like ingested these 40,000 whatever repositories. It's so unique to you, and there's no prior art, so we're learning from really first explorations, and I think that's so valuable. I was surprised when you mentioned VLLM, and I thank you very much for clarifying why. I also am surprised to find out that Llama file is supposed to be like Docker, but for LLMs, because I thought this was Ollama. Because indeed, the team from Docker did just leave and ended up, founding Ollama to be what I expect is like Docker, but for LLMs. One side note, I wish that Ollama doesn't go the way of Docker post IPO, just in the sense of I don't want a UI. Like I think when I start Docker and I get this big UI now, I'm just like I've never once wanted this. I just want to CLI. In any case, hopefully they don't anyway. But fantastic. I love also the constraints you mentioned around keeping this OpenAI compatible API, because that means less code changes in your application. So you actually spend time choosing the right tool to save time just re-implementing a bunch of your application code, right? And so this thought process is so useful for listeners as well, is like, how can we preserve our application code while changing a bunch of stuff that's bound to change anyway? I think that's really, really useful. So thank you for that. So it sounds like it wasn't hard in the end. Once you decided on VLLM as the inference engine with the OpenAI compatible API, it wasn't very difficult to swap out the calls to OpenAI with your local running VLLM inference engine now, because the API was compatible. So how long did that migration take an application led? Probably not long at all.
Not long. It sort of just became, like, okay, this is the direction we're moving. It became an exercise in deploying Kubernetes, which is always, a fun and unique marathon every time you do it. We ended up choosing Azure's Kubernetes service, which another thing I'll say is you hear me talking a lot about like layers of abstraction. One thing you may choose, the audience may choose, is to kind of stop at a layer of abstraction. There are platforms that provide, some of the open source models that just run on their hardware or like their APIs that aren't OpenAI. Maybe you choose to go all the way down to the hardware level and you're actually like deploying your own data centers that then are, building on top of this whole like layers of abstraction. For us, and really me personally having some of the expertise in Kubernetes, it made sense to stop at that Kubernetes layer, at the Azure Kubernetes service layer. So then deploying that, which then you need to write a bunch of like manifests basically to define how your applications and how your stuff is going to run. So what that ends up becoming, and I'll try to not jargon this as much as possible, but at a very high level, it became having a node group, which is just a subset of computers that run on the cluster. That node group has some T4 GPUs, which are pretty readily available. It's always interesting with the public cloud how many GPUs you can actually get at any one given time in these sort of crazy times. So yeah, we have some T4 GPUs. Those then run the NVIDIA drivers. So those actually run as their own pods on each of those nodes to actually drive the GPU. That's a critical step. And that's all, fun documentation. You can read it on Azure. Then on top of each of those is one VLLM pod. And each one of those is instructed via, the VLLM command line arguments to basically consume the entire GPU and not leave anything for anything else running on that node. And that, that's just a decision I made to be like, well, if VLLM can do this and just use the whole GPU and then do like multi-client inference, no reason that we should have, many things running on the one GPU at one time. So it sort of like effectively consumes that whole GPU, all of the VRAM, the whole thing. And then a very, very important layer of abstraction is a Kubernetes service. So I'll rewind a little bit. There's the nodes. The nodes have GPUs. The GPUs then have the drivers. And then on top of each of those nodes with GPUs is VLLM. VLLM is serving an OpenAI compatible API, and that's exposed by the pod on the cluster. And then very importantly, behind all of that is a Kubernetes service, which sort of agnostically lets you define like an endpoint that is hidden behind Kubernetes DNS and then load balanced behind all of those. And that's just something you get for free on Kubernetes, where we have 20 of these GPUs with 20 of these VLLM pods. I don't want it to just like hammer the first one because like that's bad. I have all these. I'm paying for all of them. Use that load balance service on Kubernetes to then let it, do load balancing across all those yourself. Then kind of on the other side of that Kubernetes service wall is a bunch of our microservices that actually utilize that Kubernetes service hidden behind Kubernetes DNS to then get inference. So that's maybe the best kind of at a high level, without going too much into the Kubernetes weeds on like how some of that works. Yeah.
I wanna go into the Kubernetes weeds, but before we do that, I really wanna acknowledge your note about levels of abstraction, because for me, for example, like I have built things with Kubernetes before in production at G2I, if I recall correctly, and like it's difficult. It's difficult for me because I if you look at the percentage of time I spend working on like DevOps style infrastructure is maybe 20%, and the rest is all like front end and AI and things like that. And so I'm just maybe not familiar, but also like it's a lot of YAML, and it's a lot of mapping YAML to the vendor's specific implementation of Kubernetes, which I found varies. Like Google Cloud Kubernetes is very different than AWS EKS, and so like. And then on AWS, I've got to think about, for my ingress controller, is it an ALB or an ELB? And I've got to and then in the AWS ecosystem, which is application load balancer or elastic load balancer. And then I've got to think about assigning static IPs to my Kubernetes nodes and how many and what subnets. Like it gets very convoluted. And so for me, if I was to run my fine tune with Olama, I would literally just I'd stop at the level of abstraction just before Kubernetes. So I'd find someone who hosts, Mistral 7B and allows you to maybe, Replicate. I don't know if you're familiar with Replicate. They do this, right?
Yeah.
They host models for you and allow you to do inference over API. So even I think Hugging Face has a platform there. So what I'm hearing is, for the listeners, you've got to pick your level of abstraction that you're comfortable with. It may be more expensive, but perhaps the trade-off is worth it. Otherwise, you're going to spend a ton of time trying to wrangle Kubernetes when you yourself aren't as comfortable doing so. Is that accurate?
That is accurate. Yeah, and I think funny enough, and this is sort of just how Silicon Valley tech seems to have worked for the last 20 years, is at each level of abstraction, there's going to be a business. 100% there's going to be a business. Hey, maybe you listener, I mean, this is a very green space. So, hey, maybe you listener want to build a business within one of those levels of abstraction, because I'm certain that there are gaps there are gaps within any of
Definitely.
those levels of abstraction. Like, there's nothing really that would have fit for us within like, maybe just running the model level or like having a OpenAI compatible API. So we had to kind of go all the way down to the Kubernetes level, alongside running a bunch of microservices within the cluster. So it fit very well for us. But yeah, at any level of those abstractions is going to be a business, or maybe one of the existing businesses will sort of fill that space, as we've sort of seen Hugging Face do. OpenAI definitely is filling a lot of space for that. Yeah. I think going to the level of abstraction that makes sense for you, is cost effective for you, and also that you have like good enough expertise in, is definitely a critical decision to make.
Awesome. Thank you for that. Yeah,
Yeah,
if I can try and guess, well, not guess, but if I want to say back to you the way you're using Kubernetes to run VLLM,
sure.
and have you correct the gaps in my knowledge, if
Yeah,
that's okay. So if I understand correct, from what I understand, with Kubernetes, you've got these primitive. So everything in a cluster, the first entity, so to speak, is the node, is the physical machine, right? And you could have a bunch of them, and Kubernetes will intelligently allocate resources on them depending on load. And so on a node, and nodes can have GPUs, you can provision them in Azure, right? And so nodes run pods, which are containers, instances of containers, right? And you could have like 50 running pods, and they fail over. So if one dies, the other one is active. Is that good so far? Okay. So then
that is good. Yeah.
Good, good. Okay, so then you run like a bunch of VLLM pods, and you expose them through a service, and you at some point have an ingress controller where there's an actual, like, this is an abstract concept in Kubernetes, but there has to be a concrete service in Azure that maps to this, that basically is an entry point from the broader internet across port, I don't know, 443 for TLS encrypted traffic, that then receives the request, load balances, proxies it to the appropriate pod, does the inference, and then returns. Where did I mess up?
That I would say that's all correct. I mean, obviously, there's going to be like wonky, yeah. There's obviously going to be wonky nuances
Yeah.
anywhere inside of any of those little places. Like some people will do crazy things with pods where you can have like sidecar containers alongside your main container. Blah, that's like a edge case. But yes, that's all correct. I will say though, and maybe I don't think I was clear with this earlier. We actually don't have any ingress into our cluster that's doing all this, primarily because the main operation of this whole thing, this kind of whole cluster as a single unit, is to just do basic batch processing on top of what already exists within the database. So I guess I'll kind of pop up a little the next layer to explain how that works. We have the whole time scale, right? And that's got all that data. It has like vector columns, it has summary columns and stuff. The summaries are actually very important to how this whole thing works, primarily because there's so much crap on GitHub, like so much cruft. Not even crap. It's just like a bunch of metadata that will confuse a large language model. It will. We've seen it be confused by this stuff. Look at any pull request that is like, did you sign the code of conduct? The little like check mark
Yeah.
thing in Markdown, or like, maybe somebody like cussing out a maintainer or something. Like we probably don't want to feed that to the model. So very importantly, what this whole kind of cluster is doing is actually generating those summaries, generating those embeddings, and doing that just by querying out to the database, finding missing rows that don't have embeddings and summaries, bringing that data and that metadata into the cluster, using the VLLM inference, all the way back down that whole little stack, to get the inference back up, and then actually update it, upsert it back in the database. So there's actually nothing that is trying to do ingress into the cluster. It's all egress, which I think has simplified this thing significantly. There's definitely that whole possibility where we could have an ingress controller, an ingress something, whatever Azure's version of this is, assign it like a public DNS or something. And then we could actually have like, ai.opensource.pizza or whatever, which is actually, I think, a current subdomain we have. But, that could be an API that's serving a
Yeah.
bunch of this stuff to maybe clients or a like SDK that we provide to people someday. that's definitely a possibility, but having ingress is kind of a layer of complexity we didn't go down, almost knowingly that it was going to be more complex, and that just being able to like egress a bunch of stuff onto the database was kind of simpler anyways. Just like batch upsert a bunch of stuff, and then boom, the embeddings exist in vector store. The summaries exist like right next to those vectors, right next to the rest of the metadata in the table, like we had chatted about. And then that enables our actual core API, which you can go and look at the Swagger doc at api.opensauce.pizza. That enables that thing, which runs somewhere else, to actually then start doing the actual interesting things in its backend to actually give contextual aware answers based on the vector search stuff, based on a bunch of other things that we're doing. But really the critical piece of like the Kubernetes stuff of all that is like consuming that mass amount of data, upserting and updating all that happening in the database, and then letting the API kind of do its thing down the road.
Right.
Yeah.
Does this mean you run TimeScaleDB in a self-hosted way in your Kubernetes cluster?
No, it's on Timescale's third-party service. That was something we didn't want to go down the road of quite yet. We don't want to be database administrators or really runners of databases right now. Like,
it's a service that then, sorry to interrupt you. It's a service that then persists your ingested GitHub events to TimeScaleDB. That's the service in your Kubernetes cluster.
No.
What?
Timescale. Oh gosh, what is their actual? Timescale is it's a whole company.
Right.
Timescale, just timescale.com. Obviously, it's they're running much like maybe you would see on like Supabase or something. They're running Postgres, with the whole Timescale extensions and with sort of their opinion of how that should actually work, how that should actually run. And that's a total like walled garden over there. Like that's their thing that they've been running for us, and we pay them for, and we don't want to have to manage and sort of for a very, very small team take on the risk of managing and migrating databases. That's a whole like, especially business critical data. Like we're okay at this stage paying a third party service to manage that for us. So that's a walled garden over there.
But my question is, what exactly is the service? Like, what runs in your Kubernetes cluster besides VLLM, et cetera? Because like, if it's not the database, then is it a program, a pod that gets a bunch of events from GitHub and then calls out to the Timescale API to store stuff in there? Is that the pod? Okay, that's what I was asking. Cool, that makes way more sense.
It's I always feel sort of like this crazy scientist when I'm explaining. It's like there's Kubernetes over here, and there's over this over there. But that's more accurate. Where we have this walled garden Timescale, but then on cluster we have all these like little microservices that are doing basically just batch process jobs on that Timescale. So there's never anything that ingresses into the cluster. It's all these programs on the cluster egressing out to the database to then go do updates.
When you generate vector embeddings, this on OpenAI is like extremely cheap. I generate like literally billions of vectors a month, and it costs me like less $1 or something. I don't know. So with that in mind, and these are smaller dimension. They're like 1024 dimensions. They're not 3000 dimensions with the large vector embeddings models. But in any case, that's pretty cheap. Now, do y'all, since you already have this infrastructure to run VLLM, are you all also planning to or already doing running vector embedding inferences like internally with Kubernetes, or is this something still outsourced?
That's a great question. Yeah. We do currently still outsource embeddings to OpenAI, and for a few reasons. It seems to me from some of the research I've read and some of the benchmarks, which are it's a little hard to kind of grok some of these benchmarks sometimes, because it just seems like either OpenAI is saying that they're the best, or you just read this like kind of wonky, Reddit post about like, I think this is great. Or you actually have to read like, a PhD level paper, which is, none of those are a good time. But It does seem from some of that research that I've done in all three of those categories, it seems that OpenAI's text embedding 3 model is probably the best today. And it feels sort of like the open and, Hugging Face ones you might go grab. Embedding models are like, they're just not kind of keeping up right now. And I don't know if that's just because large language models are kind of the hotness that everybody is like spending a lot of time and probably money to go and like train. But long story short is yeah, OpenAI's embedding models are like wicked cheap. It's ridiculous. But then also it seems that they're best in class. And it seems from what they've published that they're best in class, like you said, at a smaller dimension. So we actually also use a smaller dimension at 1024. And it still is just like world class. It still like nails it every time, even though it's like much smaller dimensions compared to, and really for those listening, dimensions just being the numbers, the number of numbers. So 1024 is just, we're storing 1,024 of these numbers, which is the kind of snapshot representation of what that embedding model understood by that text. You could obviously make that 3,000 something. Is that the limit these days for text embedding 3?
Yeah, it's 3,000 something. Yeah.
Yeah. You can make that much bigger and then in theory get much better accuracy. But from some of the research and things they've published, you get just about as good accuracy with a much smaller dimension, which then saves you on storage. We're not storing so much stuff inside of our database, inside of our vector store, and we can get just a tiny bit of cost savings there. So those small microservices inside of that Kubernetes cluster are also egressing out to OpenAI to get embeddings based on some of that generated text that we get off of VLLM. So it's kind of I think early on in this conversation, I had said like, oh, it's kind of a back and forth. And it really is because, we get some stuff off of GitHub from the database. We're looking at that with some of the large language models on VLLM, which is Mixtral. We're trying to like remove a bunch of cruft. We're trying to see if it's like just total garbage. We're trying to make sure that it's not going to like hallucinate. But then we're also doing an embedding based on that kind of pristine summary, so that we're not also embedding a bunch of cruft, because it doesn't really make sense to like embed like, did you sign the code of conduct check mark? That'll just confuse or just be kind of garbage data inside of these models as well. And one thing that I found to be true, and this seems to be true of any data intensive application, garbage in, garbage out. So a big part of this was just kind of grooming and removing a bunch of that crap that'll inevitably be embedded and then stored in our vector store.
Indeed. That's I'm so glad you made that clarification, but also validation for me using a smaller dimension. I thought I was a bit nuts doing that, but I'm so glad I was on the right track. Fun fact, I have a little side project that I'm slowly building, which is sort of Apple Intelligence's, semantic index. I don't know if you saw this. They talked about this at DubDub. But for the web. I've just been playing around, and I created locally. It's running anyway. A Chrome extension that just like on device. So nothing. I could do this with my internet off and just localhost, but on device creates a vector index of everything I visit on the internet. Just a snapshot of all the text content of every page ever. Not videos, because that's creepy, like Microsoft's like Windows Copilot thing. We don't do screenshots. But just text. Just take all the text, vectorize it, and store it locally. And then so far what's pretty cool is I could be like, wait, I read a paper the other day about penguins, and it would just like take me back to that point in time. It's brilliant. And all of this, again, is on device. And so when I asked about running your embeddings locally, this was my selfish reason why. I've been using Salesforce as a model on Hugging Face. Salesforce, surprisingly. It's called SFR Embedding Mistral. So it's based on Mistral 7B Instruct, and it's a fine tune with support for embeddings. I'm seeing some success with that. And so,
nice.
I'd be interested to see how the space evolves and if there's room. But honestly, given the financial cost of running OpenAI's world-class models, I don't know that this is wise, other than for the concern of like protecting the privacy of someone using this model.
Yeah, I think there are a few things that some of these models are just clearly good at, like summarizing a good chunk of text, like just being able to say, hey, model, here's this like, 4 paragraphs. Please summarize it into 1 paragraph or something, right? That is just going to be fine on pretty much any open model today. Like you do not need GPT-4 Turbo to do that.
Yeah.
Anything though that is like really cutting edge or something that like current ML and AI research is trying to solve for, stuff like complex math problems or like quantum physics problems or something,
Yeah.
or
Tool use.
tool use. Yep, that's another big one that OpenAI has nailed. Stuff like that just is gonna be pretty tricky to or probably impossible for a small large language model that is open and out there, like one of the meta ones or something. So yes, I would say that if it's like a very clearly well-defined thing that large language models just will be good at, like summarizing text for embedding models, doing obviously embedding on like very well-groomed and pristine text will also be just fine with one of the open, excuse me, with one of the open models. So that's a question I would ask yourself is like, do I need pristine, like world-class model performance because I'm going to be sending it a bunch of this stuff that really can only be handled by one of these, uber pristine models, right?
You said model performance, and now I have to ask, how did you measure the performance of the Mixtral versus the OpenAI models?
Yeah, I think that's an ongoing kind of unsolved thing we're trying to figure out. Initially, it was just kind of, I was just looking at these generated texts and being like, that seems good. Like, oh yeah,
Right.
it didn't, include a bunch of cruft and crap. There's obviously a little bit of prompt engineering in there as well, where we can kind of give the model a little bit of a head start, say like, hey, you are an open source summarization model. You will see texts from pull requests and issues. Your goal is to summarize and remove a bunch of, unnecessary metadata, period. Like that's a pretty simple prompt that actually goes quite a long way. So using more or less a similar prompt across a bunch of these open models yielded basically the same results. And I sort of feel like just because they're, kind of not being asked to do a super difficult, nuanced task, there's like summarizing a bunch of text that they have. I did really like when we evaluated them, I did really like Llama 3 for this as well. I thought that was actually pretty great and seemed to have similar performance to the, oh gosh, what is it? Mixtral 22B, is that the name of it? One of the newer ones.
8x22b.
Yes, that one. That one's also very good. That one's a little big though, and same with the Llama 370B. That one is, I mean, just excellent. It sounds like they've been training a like ginormous one that they're going to open someday, like 500B or something silly, but who knows when that'll happen. Anyways, yeah, it was more or less just like I'm looking at these summaries. I'm kind of validating that they're more or less good enough. And then I'll get into this a little bit here. Way down the pipeline, sort of at the actual application layer where you're actually chatting with this thing and getting useful information back from it. At that level, we actually do use GPT-4o with OpenAI. So we have decided to kind of consume some of that cost where GPT-4o is getting, excuse me, GPT-4o is getting a bunch of this like text and metadata and summaries off of what we had vectorized. And that does a very good job of not hallucinating a bunch of that stuff just from this wall of text that it has. And then we've also taken this whole multi-agent model approach tooling thing, which I kind of like hand rolled, which we can get into that as well. But that obviously needed OpenAI to be able to do kind of the world-class tooling stuff for these agents. But yeah, all that to say, it was not a great process, like me just evaluating these by hand. I'd love to see better prior art out in the wild in the industry because it seems like nobody has a great answer to this. It's like oh yeah, you can like use some of these platforms and like evaluating how like prompts change things and stuff. And like I know Azure has their AI Studio, which will do this. But I'm not a huge fan because it sort of asks you to deeply vertically integrate your entire stack into Azure AI Studio to then get some of that like deep data and analytics on how like things change between different models or different prompts.
Mm.
Really, what I would love is just to be able to like, I don't know, be able to like give something a bunch of texts that get generated off of one thing, and then give it a bunch of text generated off of another thing, and just for it to kind of be like, ooh, like this changed here, this other thing changed there. And I've heard whisperings, you know, kind of through the tech and AI grapevine that people are working on technologies that'll use machine learning and use more AI to kind of give you an idea of how things change as you change prompts or as you maybe would change models, which I think would be a big drastic change for your application. But I don't know. If you have any recommendations, I would love to look at them.
I mean, I've heard of two ways to make evals at this, well, with this type of application,
Yeah.
slightly more automated. One is RLHF. So at your application layers, thumbs up, thumbs down, and
Yep.
you trust your users to, I didn't like this, and then when they click thumbs down, that's already data you persist and use for your evals, but then show a quick pop up like why, and then you can also use that, right? But
Yeah.
I think that can then feed into another thing that I'm seeing really commonly, and we covered this in my discussion with Kyle Corbett, who I don't know if you know Kyle, but he has OpenPipe. This is a company that does evals as a service, among other things, and they implement a strategy called LLM as judge, where the evals are largely done by an LLM, maybe a competent one, so one of the bigger Llama ones, or even OpenAI if you want.
Yeah.
And then you do RLHF, so reinforcement learning with human feedback, on the LLM's eval. So the hope is over time you actually have to do less intervention because the LLM as judge is just really good at telling a good generation from a bad one. So that's
Yeah.
some things I've seen, but I agree. There's not that much prior art, and I think we will actually. I think we're guaranteed to see either a company start here or prior art appear in some way, shape, or form.
Yeah.
I wanna maybe start wrapping up with one final question, which has
Sure.
nothing to do with AI, but you're a Kubernetes expert, and I would be remiss if I didn't ask this. Earlier in my startup career, there was like we used Kubernetes for like a company with maybe 30 users, and it ended up being very expensive, right? Because these are not one machine, but they're many machines that are on all the time.
Yeah.
There's a transport provider here in Europe called Flixbus. They're actually a very big tech company, and I have a friend, a colleague who used to work there, who would tell me he had like enforced work-life balance because after 6 p.m. they just shut down the developer Kubernetes cluster and they just can't develop against their dev environments because it's a cost-saving thing.
Oh my
And I was
God.
like, why did they use Kubernetes for your developer environment? Why don't you just run it anyway? So it was an interesting discussion, and a lot of folks go. There's a lot of hatred around Kubernetes by some circles of developers because it's too expensive, and it's either too expensive or it's too complicated to configure. And I've also seen a trend of like early startups, and open source is an early startup, I think.
Yeah.
And of course you're the expert, so I think if you decide to use it, it's with good reason. But I've heard a lot of early startups adopt it, and the disgruntled engineers say, "Oh, it's just the CTO wanted to use it because it sounded cool." Now, with all of this context, can you comment on any of that? Like, why maybe does open source use it, and what is the ideal sort of milieu in a startup to reach for such a tool? Because again, the reports I'm hearing is a lot of folks don't need it, but they do it. In fact, I think somebody even, it's a meme, like you may not need Kubernetes.
Yeah. Oh, it's definitely a meme. And I would say if you're not operating at the kind of data scale that we are, you don't need Kubernetes. Or at
What
least,
scale is that? Like
well, I
is that the
mean,
40,000 repos and these live
yeah,
events every?
yeah.
Okay.
And then plus more. You know, it's a pretty conservative estimate. You know, and then the millions and millions of vectors that we're doing and all that stuff, and needing that off of, you know, many scaled up VLLMs. And you know, it even for us, I was very, very, very cautious adopting Kubernetes, even at this level. We don't have an ingress. It's not like we have a live service that actually needs to be running all the time on this thing. If the whole cluster went down today, OpenSauce would continue to operate as normal. End users would not notice because, you know, really the only thing that is informing Star Search is like new and more current embeddings and summaries. So really, the thing would just kind of maybe stall in like not having the most up to date latest information, which is fine. It seems like a lot of AI enabled applications, like end users, are just okay with things being a little old. Yeah, I was very cautious even at that level adopting it because it is operational burden. It's a lot of operational burden just even at this level without ingress or like critical infrastructure running on this thing. That trade off though, being able to have like at any one given time scale up a bunch of GPUs and be able to run a kind of agnostic OpenAI service that runs on our own hardware is expensive, but conversely, we're not paying tens of thousands, hundreds of thousands of dollars to a third party provider. We're using some credits at like, 500, $800 a month for a single cluster, basically. And then obviously, if you were to scale that up to dev environments, test environments and stuff, you'd be, scaling those costs with the clusters linearly. So I think that it really, really, really depends on ultimately like the level of scale and usage. And I really like Kubernetes, and I can only say that after like 5+ years working in it deeply. Even at Amazon on, working really, really closely with the EKS teams, working on Bottle Rocket, which is a node provider, is the operating system that provides a node to EKS type clusters and stuff. It's a really, really gnarly technology all the way down, even at a very high level where it's like, oh, I'm deploying pods and I'm deploying daemon sets and I'm deploying, scale sets or whatever and stuff. I mean, as soon as you go any deeper than that, it gets pretty gross. Like if you're working on controllers, which is a slightly lower level down where you're actually like programmatically building on top of the platform. Obviously at the node layer is pretty insane. Yeah, it's crazy. On the other side of that, I'll say that in my opinion, it's the only platform, the only compute platform that exists today that has buy-in from all of the major clouds. In my opinion, it's like probably the most vendor agnostic tool that we have of this scale today. And then you can take it from absolute zero to hero along the journey. And I think that's maybe why some very, very early stage startups adopt it in the way that they have. I think today I'd be pretty cautious moving like our critical API infrastructure onto Kubernetes. Because right now that just runs on like a container platform on DigitalOcean, which is like so easy and relatively cheap, and I don't have to touch a lot. The trade-off there is that there's not a lot of ways to configure it. Like one kind of pain in the neck that we've had to deal with is like how logging works on those services. Like you don't just get a log sync that I can just like shill logs out to Datadog or Grafana Loki or something. It's kind of all on DigitalOcean's platform. What you get instead on Kubernetes is something that will scale with you to unicorn status and beyond. There's a reason that Google runs Kubernetes, and there's a reason that every major telco company runs Kubernetes. It's because it scales with you no matter what.
Yeah.
So if you're at a stage of your company or you're thinking about building something and you're thinking about reaching for Kubernetes, remember that. Like if you're not approaching or even imagining approaching Kubernetes Google scale, there's no need, honestly. And you could even make that argument for open source. Like while we do consume many millions of events every day off of GitHub, there's probably smarter filtering we could have done to, kind of abstract some of that away. But for me, having a lot of that expertise, I was okay taking on that personal operational burden to bring that kind of scalability really quickly to our product. So these are all really personal questions you have to ask not only yourself, but you have to ask of your team, and you have to ask. You have to ask of your product. Excuse me.
Yeah.
So team, product, personal. It's not a one size fits all solution, and not a one size fits all answer.
Wow.
I love it. Such nuance, and I so love the acknowledgement that it is a meme and it is often misadopted, but the fact that it will scale with you to unicorn and beyond.
Yeah.
John, listen, I know it's been a really awesome discussion, super in depth. Your article was masterful. The discussion more so.
Thank you.
We covered so much. We covered VLLM and Llama and Llama CPP, and going from, I think it was $4,000+ a day estimated to the cost savings that you share in this blog post. On behalf of myself and all the listeners, honestly, I cannot thank you enough. Thank you so much for coming on and sharing this with us today.
Well, thanks for having me on. Yeah, this was delightful. Appreciate it.
Thank you for joining my discussion with John McBride. I hope you found it as insightful and as inspiring as I did. In fact, it's so cool now knowing how to build something like ChatGPT on my own infrastructure at my own cost, and I've actually done so. If you want to know more about that, follow me on X and we can talk, or LinkedIn. If you're learning from and or enjoying this content, and since it's a relatively young podcast, the great way to support it is to subscribe on YouTube, Apple, and Spotify. If you like the content on YouTube as well, that would be a huge help. On Spotify and Apple, you can leave up to a 5-star review, and each of those would help the podcast grow and signal to me your interest in having me continue it. This is an experiment, and there's no guarantee that it'll continue unless there's enough interest, of course. So also, if you share it with your friends on your networks, LinkedIn, X, all of this will help the podcast tremendously at zero cost to you. Thank you for sticking around. Thank you for being a part of the podcast. And most importantly, thank you for your interest in engineering.